Hi, welcome to part 13 of the video series about vertical projectile motion. In the previous videos, we have learned how to draw acceleration and velocity versus time graphs of an object in free fall. In this video, we are going to learn how to draw position versus time graph of an object which is doing vertical projectile motion. Drawing position versus time graphs is one of the most complicated parts of this topic, as we have to know how to express the position and time as a quadratic equation, and then how to draw parabolas for these complex formulas. But don't worry, in this video we are going to learn how to draw these graphs without all this hassle. If an object is in free fall, and by the way, the rocket on the screen is not in free fall, but we assume it is. If an object is in free fall, to draw its position versus time graphs, the only thing required is imagining the trajectory of a soccer ball kicked from the ground. Here we have a ball resting on the ground. When we kick the ball, it is moving forward and upwards as can be seen on the screen. The arc represents the path that the object follows. It does so until it reaches the maximum height. Afterwards, it will start to fall down while continuing to move forward as well. Then it will hit the ground and bounce off to repeat its motion of going upwards and then downwards. This motion can repeat several times. To keep it short, we stop drawing the motion after 3 occurrences. The diagram represents the path of an object which was kicked from the ground, but we can use it to draw the position time graph of an object which is thrown upwards. The only thing we must do is to remove all the distractions from the screen and keep just the path. Then add x and y axes so that the beginning of the path is the origin of the graph, and we are done. What about the cases when instead of throwing the ball upwards, we throw it downwards or release from certain height? Releasing ball from a certain height means we start the motion from the maximum height. In this case, we can skip the first part of the graph and plot it as a trajectory of a ball kicked horizontally from a certain height. That's all good, but there are some points we have to consider while drawing these graphs. One of them is the time of contact of ball and surface during bouncing. In the previous graphs, we have assumed that there is no time of contact, therefore there is no loss of energy as well. Which brings a question to the mind. How we draw these graphs if there is time of contact? This is the graph without time of contact. When there is time of contact, there will be slight gaps between each semi-arc which can be represented as delta t. This is the duration where ball and surface are in contact with each other. Another point to consider is that if there is time of contact, the collision is an inelastic one. In other words, there is loss of energy. If an object loses energy during the collision, after bouncing, it cannot reach the same height as before. Therefore, the height of the second and third trajectories will be relatively smaller than the previous one. Another point which we have to take into consideration while drawing position versus time graphs is the reference point. This is especially important for the graphs of the objects which are thrown downwards or released from a certain height. In the graph we have drawn before, the ground level was chosen as the reference point. Reference points are considered as the 0 points. Choosing ground as the reference point means that when the ball hits the ground, its height is 0. We can imagine it as like someone has kicked the ball from a certain height and we look at the ball from the ground. We can also choose the initial point as the reference point. In this case, initial height will be equal to 0 and the ball will fall below the initial point. We can imagine it as we are the ones kicking the ball from a certain height and then the ball falls and bounces off the ground below us. To conclude this topic, we have to consider which direction is chosen as the positive direction. In all our examples, we were considering upwards as the positive direction and have plotted the graphs accordingly. There is only a slight change for the cases where downwards is assumed as the positive direction, and this is flipping the graph against x-axis. The process is the same for all different graphs we have seen in this video. Even though we have tried to simplify the concept, there was still too much to cover. Therefore, please let's take our time to digest all this information. In the next few videos, we are going to solve some examples to see all this knowledge in action. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.